This assignment requires the use of Australian standards in the design of shed structural components, which includes the use of AS 1170.0, AS 1170.1, AS 4055, and AS 4100. Sheds are constructed of 4 typical structural members: columns, beams, purlins, and girts. These members support the loads of the structure while supporting their own self-weight. Generally, the use of universal column and beam sections are used, with girts and purlins being C and Z sections. Next up, steel structural members. Columns are important structural members as they transfer load from the roof to the slab. Columns are designed to support the various loads from vertical and perpendicular directions. Loads applied to the roof are generally supported by the rafters, which transfer loads to the columns. These are designed using universal beam sections. Girts and purlins support perpendicular loads depending on their orientation. These are attached to the columns and beams, which also receive the transferred load from the purlins and girts. Types of loads. 3 types of loads were considered during this project, including dead load, live load, and wind load. Dead load is denoted as G in Australian standards and is the self-weight of the structure and typically follows a vertical path. The next load is live load, which is denoted as the letter Q in Australian standards and is imposed load or load applied to the structure. This load differs from dead load and is not continuously applied to the structure. The final load is wind load, which is denoted by W. This load is different as it is applied by the wind itself and is a pressure on the structure, typically horizontally. This load is dependent on the region, terrain, and shielding of the structure. Requirements for the project. The structural design of the shed was to meet certain parameters, including 150 mm thick concrete slab, a span of 7 metres, a height of 8 metres, an overall shed length of 12 metres, a base spacing of 6 metres, a 5-degree roof pitch, a wind region of type A, wind terrain 2, shielding partial, and with all design and all requirements were to be met, or the structure could face possible failures. Wind load calculations. The wind load is calculated based on AS 4055. Included in this was the method of calculation for wind design of the structure. The external wind pressure of the structure was determined first, which was based on the density of the air and the pressure coefficient. Wind load calculations are important in determining the load combinations of the structure. Load paths. Load is transferred between members and through structures. Load paths through shed structures typically follow a path based on vertical and horizontal loads applied. Vertical loads or gravity loads are transferred from the roof sheeting to the purlins and then through the rafters, columns, and finally into the foundation and footing. The other loads applied, which are horizontal loads, are applied to the wall cladding first, and then the wall girts, to the columns, and finally to the foundation and footings. The vertical loads are typically dead loads and live loads, and the horizontal loads are typically wind loads. Bracing. All structures must have bracing to support the structure, otherwise the horizontal loads will cause the structure to fail. There are 3 types of bracing for structure: diagonal bracing, rigid joints, and shear planes. Which bracing is used for the structure depends on the type of structure. Bracing configurations are also included in the image displayed on screen. Bracing for the shed was designed as seen in the image displayed on screen. This bracing was created based on the horizontal loads of the structure. Bracing plays an important role in strengthening structures to resist horizontal loads. Finally, for part 1, steel connections. 2 different types of connections exist, such as rigid and simple connections. These both have different advantages and disadvantages. Rigid connections are moment transferring connections, and simple connections do not transfer moment. When designing the structure, all rigid connections were used. When a beam-to-beam connection is created, they are bolted and become a simple connection. This changes when a form of moment restraint is added to the connection, such as a stiffener, and moment is then transferred. Part 2. Determining loads is an important aspect of the design process which requires the total weight of the structural components such as C1, B2 and B1 sections. These loads were then to be input into the load combinations set out by AS 1170.0/2002 to determine the critical load combination. These load combinations would determine the resulting bending moment, shear force and deflection. Once the load combination for the structural members were complete, the bending moment, shear force and deflection were to be determined. The maximum values of these were necessary for the design of the beam sections and column sections. Space gas was used to create an analysis of the intermediate frame of the structure. Using space gas features, the analysis performed determined the bending moment, shear force, deflection and axial force. Then a comparison between the space gas model and manual calculations was made. As the space gas model was split between dead load and live load cases, the result differed. This is due to the manual calculation using dead load combinations which combined the two load cases used in the space gas analysis. AS 1170.0 uses ultimate limit state or load combinations which include safety factors and ensure safe design. Finishing off part 2, purlin design. Purlin design is similar to the process of beam design as many of the same steps are followed. Purlin design typically includes the determination of loads which is based on materials, followed by the load combinations for the strength limit state, which requires inward and upward purlin line loads to be included. The purlin can then be checked for serviceability and designed. Finally, we've come to the conclusion of the presentation. Structure design is a complex process which requires many different aspects of a building to be considered. Aspects such as structural members, loads, building requirements are integral to the process. Also, a wide variety of beam and column sections are provided in the market. To determine the best fit for the project, manual calculations as well as engineering software modelling can be used. Engineering design is an important step to providing safe and economical structures for clients. Finally, thanks for watching.